Okay, so hi Older. I'm Nat, and I'm a chemistry major student, and this is my senior project. And I actually found my mistake because I think it's very hard to see if I try to do like a portrait PowerPoint. Because when I'm gonna show you, it's very difficult to read the text, right?
Yes.
Yeah. So do you prefer me to keep it like that, or you want me to show you like this way? I think this will be easier for you to see, right?
Yeah, it's easier to see that way.
Okay, yeah. So I'm gonna go ahead and introduce you my project. What we are doing right now, we are trying to synthesize a sulfonated surfactant, which is look like the methyl orange. It's something like this. It's have the two benzene ring connected to the connected by the and then double bond the azo coupling, and there will be the sulfonated over here, and which are linked to the long chain carbon.
Mhm.
So we decided to separate the project into two parts. The first part is trying to make this long chain aniline substitute. So what we do, we dissolve the one promodecane with an excess of aniline and reflux it at 80 degree for 36 hours. And then we wash the solution with 100 ml of 5% sodium hydroxide, hexane, and a lot of DI water, trying to remove the aniline from the solution. And then we rotary evaporate the solution. And finally, we perform the column chromatography, trying to remove all of the excess aniline. The aniline will be trapped on the top of the silica, and what we collect, which is the bottom here, we collect all of the N-decoaniline. And in order to test the purify of the stuff that we make, the 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 purify of the N-decoaniline, we perform the IR, carbon AMR, and also the TCL. In the IR, we saw the signal of the amino group, which is about 3409. And we saw also some CX stretchings over here, going from 3000 to 3852. We also
Mhm.
see the signal of the C double bond C, the conjugated system, so around 1600 to 1450. Next to the IR, we collect the NMR. The solvent we use is the chloroform. And what we collect, we got the signal, the upfield signal, which is the signal for the hydrogen belonging to the CH3. All the peaks over here is the signal of the hydrogen belonging to the CH2. The signal, the small signals over here, which is around 3.46 to 3.49 ppm. That's the signal of the hydrogen belong to the amino. All the signal downfield, the one over here, those are the hydrogen in the benzene ring. And next to the we also have some we trying to like, let me show you. So, and we also doing some integration, but I don't think like it's matching what we trying to looking for. We only have like three like as you can see here, there's only the CH3 is only have three hydrogen, but the value we got is around five, so I don't think is matching what we're looking for. Beside the carbon, the TCl, which is very useful, that we know that we are making some peer stuff. That's what we got at first when we haven't removed the excess aniline. After refluxing, we collect the sample, and as you can see, there's a signal for the anilines over here, and also like other stuff like the impurity stuff. Comparing to the one that we collect out at the end, like it's very pure. It looks exactly like the reference we got, and pretty much that's what we are trying to do right now, and we're currently still working on the next step, doing the sulfonated over here, and I plan to continue my research on summer and also in the fall semester.
Cool. Yeah, I was gonna ask you like when you were planning on continuing, but yeah, so summer and fall. On your column chromatography,
Yeah.
besides the silica, what did you like use as a solvent?
Oh, the solvent we use we use the hexane and the ethyl acetate. The ratio is 1 to 5, so 1 ethyl acetate and 5 of the hexane. I use about like 300 ml, so would be 15 I'm sorry 50 mil of the ethyl acetate and 250 mil of the hexane.
Was there a reason why you did a 1 to 5? Or like, did the literature say that?
Uh,
Like,
pre yeah, I mean like the column chromatography, it work exactly the same like the TCL, because we also use the silica, which is the backside material of the TCL. So
mhm.
we trying to make the solvent that like when the like like separate the polarity of the stuff, so all the stuff will be transferring through the silica, and so we can trap this over here.
Okay, awesome.
Mhm.
Oh, pretty cool. Cool, cool, cool. Thank you. I mean, good presentation. A lot of like information. It seems you got.
Mhm. Yeah, thank you so much.
All right. Uh, I'll go visit other people's booths.
All right, good luck, see you then.